Hello, this is Mrs. Workman. Use the exterior angle inequality theorem to list all of the angles that satisfy the stated condition. All angles whose measures are less than the measure of angle 2. All angles whose measures are greater than the measure of angle 3. Before we begin the problem, let's review what the exterior angle inequality theorem states. It states that the measure of an exterior angle is greater than the measure of either of its corresponding interior angles. Now let's go to the diagram. In this first statement, we're talking about the measure of angle 2. Right there it is. And I noticed that angle 2 is an exterior angle for this triangle right here. It's also the exterior angle of this second triangle. So the first thing I'm going to do is I'm going to trace this first triangle. So we just look at that one. And by the exterior angle inequality theorem, I know that the measure of angle 2 is greater than the measure of angle 4. That's one of its remote interior angles. I also know from this theorem that the measure of angle 2 is greater than the measure of angle 1, because in this triangle, angle 1 is also a remote interior for angle 2. Let me erase this. Here's angle 2 again. This time, let's consider the large triangle. Again, I'm just sketching it in so you know where we're looking. 2 is an exterior angle. Notice that in the larger triangle, angle 3 is one of its remote interior angles. And this angle right here, which is angle 1 plus angle 7, is its other corresponding remote interior angle. So that tells me, the exterior angle inequality theorem tells me that the measure of angle 2 is greater than the measure of angle 3, and also the measure of angle 2 is greater than the measure of, this angle, which is the measure of angle 1 plus the measure of angle 7. Now these are all true statements based on the exterior angle inequality theorem. Let's go back to the statement we were asked to satisfy. All angles whose measures are less than the measure of angle 2. So, angles with measures less than the measure of angle 2 would be angle 4 from this statement, angle 1. From this statement, we're told the measure of angle 2 is greater than the measure of angle 3. So angle 3 would have a measure less than the measure of angle 2. And from this statement, the measure of angle 2 is less than the measure of the sum. We already know it's less, the measure of angle 2 is greater than the measure of the sum of these two angles. We already know that the measure of angle 1 is less than the measure of angle 2. Now we know that the measure of angle 7 is likewise less than the measure of angle 2. So angles with measures less than the measure of angle 2 are these. We'll move on now to the second part. Now we want to know all angles whose measures are greater than the measure of angle 3. Well, I'm going to leave the diagram that's already up here first. Notice that angle 3 is part of this larger triangle, and angle 3 is a remote interior angle for exterior angle 2. So by the theorem we've been quoting this entire problem, we know that the measure of angle 2 is greater than the measure of angle 3. Now let me erase this again. And let me trace this triangle, because you'll notice angle 3 is also part of this smaller triangle. And in this case, angle 4 is an exterior angle with respect to angle 3. So by the exterior angle inequality theorem, we know that the measure of angle 4 is greater than the measure of angle 3. Now this statement says list all angles whose measures are greater than the measure of angle 3. So angles with measures greater than the measure of angle 3 would be, according to these statements, angle 2 and angle 4. All of these answers we were able to surmise using the exterior angle inequality theorem.